Some claim that quantum physics proves things can happen without a cause. If true, does this mean the universe could pop into existence from nothing? Let's take a closer look. In my previous video, we explored the concept of the uncaused cause, the idea that something must exist outside of space and time to explain the existence of the universe. If you haven't seen that video yet, I highly recommend checking it out as it lays the foundation for this discussion. Quantum physics is the study of the tiniest things in the universe. Things so small, they don't behave like anything we see in everyday life. Instead of acting like tiny marbles, particles behave more like waves of possibility. They don't have a set position until they're observed, and they can even seem to be in two places at once. This has led some people to claim that quantum events happen without a cause. But is that really true? When we think of tiny particles, we imagine them as little marbles moving in a straight line. But in quantum physics, particles behave very differently. Scientists tested this by firing electrons at a barrier with two slits. If electrons acted like tiny marbles, they should go through one slit or the other. But instead, they formed an interference pattern on the screen, just like waves do when they overlap. This suggested that each electron was behaving like a wave, going through both slits at once. But here's where it gets even stranger. When scientists placed detectors at the slits to see which slit each electron went through, something changed. The electrons stopped acting like waves and instead went through one slit or the other, just like normal particles. The simple act of observing them caused them to behave differently. This means, before we observe a particle, it exists as a wave of possibilities. But observation forces it to take on a definite position, behaving like a particle. This shows that observation itself is a cause. It physically changes the outcome. Because quantum events appear unpredictable when they're not observed, some claim this proves things can happen without a cause. Quantum fluctuations, for example, seem to create particles out of nowhere, leading some to argue that the universe itself could have come into existence uncaused. These events aren't truly random. They follow precise mathematical equations. They may be unpredictable to us, but they still obey structured rules. Even though cars on a busy road seem chaotic, they all follow traffic laws, speed limits, stop signs and signals. Drivers make independent choices, but within a structured system that keeps order. Quantum mechanics is the same. It might seem unpredictable, but beneath the apparent randomness, there are strict mathematical laws governing how particles behave. Empty space is not nothing. Some say particles pop in and out of empty space. But in quantum physics, an empty space isn't truly empty. It's filled with quantum fields and vacuum energy, an invisible sea of energy fluctuations. Imagine an aquarium filled with water. To a fish, the water might seem like empty space, but it actually contains dissolved oxygen, currents and energy that affect everything inside. Quantum empty space is similar. It isn't truly empty, but filled with invisible energy fields and fluctuations. True nothingness would be like an aquarium with no water, no fish and no glass tank, completely absent of anything. That kind of nothing doesn't exist in physics. Quantum particles creating more particles still requires a cause. Some particles seem to create new ones, but this follows strict physical laws. When you strike a match, a small spark can ignite a whole fire, but the fire doesn't appear from nowhere. It requires oxygen, fuel and heat. In the same way, quantum particles can produce more particles, but only within the right conditions. These reactions follow strict laws and don't happen in true isolation. Probabilities still require a system. Some claim that because quantum mechanics operates on probabilities, things can happen without a cause. But probability does not mean causelessness. Think of throwing a die. You can't predict the exact number, but the roll isn't uncaused. Gravity, friction, and the way you throw it all determine the result. Similarly, quantum mechanics describes probabilities. but those probabilities exist within a structured system, governed by laws. Here's what scientists can predict, versus what they can't explain. The probabilities of where a particle is likely to appear, how quantum systems behave over many repeated experiments, the behaviour of quantum waves before observation using precise equations. What they can't fully explain, why a quantum particle behaves as a wave before measurement, but as a particle when observed. Why observation causes the wave function to collapse into a definite state. Even though science can't fully explain why this happens, the fact that it does proves that something is causing it. Quantum mechanics is real, but it has limits on what it can explain. The fact that observation affects reality suggests that interaction, some form of cause, is necessary for things to take shape. Even though we don't fully understand why particles change when observed, the change itself proves that something is causing it. This means we, at the very least, are instrumental in the causal effect. And if quantum mechanics reveals an underlying order in nature, doesn't that raise an even bigger question? What or who is behind that order? Some also argue that the multiverse removes the need for the first cause at all. In my next video, we'll take a closer look at that claim. So what do you think? Let me know in the comments, and don't forget to like and subscribe. Take care, and I'll see you next time.